Today we're focusing on geometric sequences. The first thing I'll be covering is the general term of a geometric sequence. Be given to you on your formula page. Tn is equal to a times r to the n minus 1. So this n minus 1 is only applicable to r. It's not applicable to a. Okay, so that's the general term. That's on your formula page, where a is the first term, r is the constant ratio. So the constant ratio we get by saying term 2 over term 1, or term 5 over term 4, or term 10 over term 9, and so forth. That's how you get r, your constant ratio. For now, I think let's just use term 2 over term 1. So let's look at a question. Consider the following geometric sequence. So they tell you it's geometric. The first question is to find the general term. So to find the general term, we write the formula down from our formula page. And we simply sub in a and r. So let's see. A is the first term. So if I look at this, a is 3. And r is term 2 over term 1. So let's look at r. R is then 6 over 3, which is 2. Therefore, the general term Tn is equal to a, which is 3, times r, which is 2 to the n minus 1. And there you have it, as easy as that. That is our general term. The second question is calculate T10. So to calculate the 10th term, we simply sub in 10 in the place of n over here. So we take the general term and we make our n 10. And we get our 10th term to be equal to 1536. Okay, let's look at the last question, question 3. So it says, which term in the sequence is equal to 6144? So when it says which term, we are solving for n. Let's write the formula down from the formula page. So on my formula page, Tn is equal to a times r to the n minus 1. But I worked out Tn already. It is 3 times 2 to the n minus 1. But now which term is equal to 6144? So I make my general term equal to 6144. And now I do the algebra. With geometric patterns, you need to know your exponential rules. So to get n by itself, I'm going to divide this side by 3. But what I do on the right, I have to do on the left. So this 3 and this 3 will cancel. So 2 to the n minus 1. 6144 over 3 gives me 2048. And now, with exponents, I need to make the base numbers the same. So I'm quickly going to show you how to make the base numbers the same. To make the base numbers the same, you're going to take this number, 2048, and you're going to press equal, shift, and you're going to look for fact to write it as an exponent. So I'm going to show you here. So I'm going to write 2048 equals, then shift, and then fact. So where is fact? So fact is there, and there you see it gives me 2 to the power of 11. So then I write 2048 as 2 to the 11 is equal to 2 to the n minus 1. Once the base numbers are the same, they fall away. So I'm left with 11 equals n minus 1. So n is 11 plus 1. So n is 12. So therefore, term 12 is equal to 6144. That's how you do that question.